Correlation regression is a topic that's usually at the end of an intro to stats book. So I wanted to take a moment here at the beginning to talk about why I think it's appropriate to do at this point in the course. So coming straight out of part 2, we're going to do a baby review and sort of say what we have learned from that section. We started part 2 with a section saying, how in the heck do we deal with one categorical variable? What can we do to get as much information about a single categorical variable as possible? And we had 3 options. The most simple thing we can do is just make a frequency table. So instead of having a giant list of all the categories, tally them up, figure out how many people fell into each, or how many observations fell into each category. We could make this a little fancier, display the information from this frequency table using either a bar chart or a pie chart. In 2.2, we got slightly more sophisticated. We talked about how do we look and investigate a relationship between 2 categorical variables. For instance, if we wanted to investigate how gender might influence major, what could we do? And we broke that down in our class, right? Doing a contingency table. This is where we had one categorical variable as the rows, the other as the columns, and we were able to answer all sorts of questions, sort of just generally look quickly at that relationship. We do have a couple of ways to display this, though we haven't played very much with them. One would be a split bar chart, and the other would be a stacked bar chart. So still using that example of gender and major, a split bar chart for a particular major, ooh, that's not what I meant to do. A split bar chart would look something like this, where you'd have your men and your women side by side for a particular major. So this would be your males and your females for a particular major. Let's say this is communications or something. So you could actually go into each one. A stacked bar chart does the same thing, except for it stacks everybody in the same bar. It just splits it in color. This way, if you're looking at communication, you can actually see its overall versus the other majors, and also look into the sort of breakdown of gender within that. So that's how we could look at a relationship between 2 categorical variables. After that, we went into a lot of information about how to investigate a single quantitative variable. Now, to look at a single quantitative variable, we have lots of ways that we can quickly summarize, like our mean and our median. If we want to look at center, we have our standard deviation and IQR if we want to look at spread. And we had a number of different displays, and I'm focusing on displays at the moment. So display-wise, first thing we talked about was a histogram. In the same section, we discussed dot plots, as well as stem and leaf plots. And then we finished up the part 2 with our discussion about box plots. And box plots were even greater than being able to just look at a single quantitative variable, because they gave us a way to look at a quantitative versus a categorical, right? In a box plot, what we were able to do was to investigate a relationship, right? We could sit there and say, okay, for category 1, here's what our box plot looked like for our quantitative measure, right? Category 2, here's what it looked like. Okay, it was much larger in category 2. We could even have a category 3, right? Say, oh, they had the smallest values and they were very tight together. So we were able to investigate a relationship. In this whole bottom half here, we were able to look at relationships between either 2 categorical variables or a quantitative and a categorical, which is why part 3 flows directly from this sort of trend that we've been doing. We looked at how to look at a single variable, and then we looked at how to look into relationships. And that's exactly what we're doing in part 3, is we're going to be looking at a relationship between 2 quantitative variables. So our first example here is actually almost exactly like what we did in class for the activity. We have Leonardo da Vinci using measurements And we have a graph of a sample of 55 males looking at height and their left arm length. So the first thing we're asked to do is to say, what can we see in the scatter plot? So take a moment, look at it. What's going on? Think about those 4 pieces that we talked about in the activity. First of those 4 pieces was to look at our direction of the relationship. We can see here we seem to have a positive relationship or a positive association. What this positive association tells us is that as height increases, arm length increases. This is set up the opposite of the way we did it in class, but it's the same idea. So we were trying to think more like a paleontologist or forensic, I can't even think of the word. It's going to drive me crazy. But you know what I'm saying? Look at whatever I said in that thing. And the idea being that you'd more likely have the arm bone or arm length without having the true height. So we wanted to kind of go the other direction. Okay, what else can we see? Well, the next thing we came to was form. What does it look like? Is this got a linear trend? Does it have an exponential? Does it have a logarithmic? A lot of people got carried away looking at the actual graphs I provided and not just thinking about what does it mean to increase linearly? What does it mean to increase exponentially? So to increase linearly means that we have a constant rate of change, right? A constant increase. It's not going to do anything crazy. So that's linear. Exponential means that it starts out slow, but then it gets exponentially larger, right? This is like bunny population. So do you see that trend? Logarithmic, it increases quickly, but then it levels off, right? And then I also threw quadratic in there. Quadratic has that sort of vertex, right? The parabola shape. Does it go up and then back down and level off? So this is what you're actually asking yourself. And this is by no means all of the different things that we've learned about in algebra classes, right? Especially if you've taken trig, you could imagine having something that has that sine kind of curve. It's periodic, sort of like that time plot we saw in part 2. So there's a lot of different options here. What we are hoping for always in this section, because it's the only thing we learn in intro stats, is for that linear relationship. If we have a linear relationship, we can actually go do something. The rest of these, we technically don't know how to handle or won't learn how to handle in this particular course. So if we look at this pattern, it does appear that we have a linear relationship. We also talked a little bit about strength. Strength is about how close all these things are to the trend. So in this case, that's pretty strong. We don't have a very good reference for this because we haven't done a lot of scatter plots. So we're going to leave this off my description. And instead, we're going to focus on the last piece here, which is there anything unusual to talk about, any outliers that we could see? And so if we look at this plot, outliers can be, oh, look, these people are just really tall. But they're really just more outliers on a single variable, not on the 2-variable relationship, right? Especially this particular observation is right on trend. So that's not going to be a big deal to us. What we more want to look at is people who are off trend. So the furthest things from our line are probably these 2 points, right? So they are the ones that we would call out as possible outliers. And these possible outliers, which whenever you say this, you need to tell me where they are. So we'd say say it's about 62, 26, right? It's an ordered pair, x comma y. And then let's call that what, 73, 23. And let's actually talk about what they are. This person is very tall, but has very short arms, right, for their height. So this is our T-Rex person. And this person is very short but has incredibly long arms, like a monkey. Which I can say because I have long arms for my height. So let's move on. We're going to go ahead and create a scatter plot in this next section. I know you guys already know how to do this because we did it in the activity, but I'll break it down. So first thing when you're making a scatter plot is you should decide which is your X and which is your Y variable. I did this for you in the activity, so I actually made life a lot easier on you. So here we're looking at cricket chirps versus temperature. So if we look at this, what we need to decide first is which is more likely, right? If there is a directional relationship that we can talk about, we should make that happen on our graph. So X to Y, which is more likely? Do chirps influence the temperature, or does the temperature influence the chirps? Which of these? And hopefully right away you're saying, okay, this makes way more sense. No way those little crickets are like rubbing their legs together so fast to create friction and change the ambient temperature. More likely they chirp based on the temperature. So we're going to go ahead and then put temperature down as our explanatory variable, right? The other one, our independent variable. And as our dependent variable or our response, we're going to put down our number of chirps. And this will be per 15 seconds. I should put down what the units are. This is in Fahrenheit. All right, so we've got everything down. Then we need to figure out, all right, what's the scaling down at the bottom? What should I start with? What should I end with? We do not need to start at 0. That's only true when we're talking about frequencies in bar charts. For this, we're going to look and say, okay, temperature, our minimum temperature appears to be a 47. Our maximum appears to be an 89. So I'm going to go from a 40 to a 90. So I'll start at 40. 50, 60, 70, 80, and 90. And on my chirps, looks like I'm going from a 6 to a 50. So I'll just go from 0 is fine up to 50. So 10, 20, 30, 40, 50. The scaling does not have to be the same. It is nice if it can be, but it won't always work out that nicely for us. And then we are going to go ahead and just put each of these things in there as an ordered pair, right, as one observation. So at temperature of 47, we should have about 6 chirps. And this is going to be a true and utter guesstimate. You would usually use technology to do this. We're doing it by hand now because we are. So I'm going to go ahead and just fill this in. And there's my graph. So we have very similar things to talk about from the previous graph. We still have our positive linear trend. This particular relationship seems a heck of a lot stronger than our one with the height and the arm length from our example before. And there's not really any outliers to talk about here at all. We could maybe talk about how there was one particularly high temperature, but even then, it's right on the trend as everything else. The next page just goes ahead and talks about all those different things that we broke down in our activity, the ways that we interpret our scatter plot. So again, we have our direction of the association, positive or negative. Just think about whether if you fit a line, your line of best fit would have a positive slope or a negative slope. Our form, again, linear or nonlinear. I'm not going to make you know if it's logarithmic, exponential, quadratic. All you're going to have to do is determine is it linear or not. The strength, strong versus weak. And then outliers or groupings. Groupings are not always this easy to spot. You may see something like those, I think the first 2 classes we looked at mom height versus our height. And then it was very interesting to look at, oh, the women were grouped in a certain area and the men were grouped in a certain area. Maybe it's inappropriate that we have those 2 things combined. But you can't see that unless you actually color your points differently or mark them differently. So we are done with scatter plots, and that's all for 3.1.